This is Team 11. Going to be talking about some hardware, code, and debugging for our receiver and transmitter for our Quadruped project. So let's talk about the hardware first. What we have set up here, you can see we have our ECEN2440FinalProject. We also have a SparkFun Redboard Arduino, and then we have a basic joystick here, 2-axis, horizontal, vertical. It's also got a switch on it as well, so 3 outputs. And then we have our RF link transmitter right here, RF link receiver. So how this set is set up is we have our Arduino on a 5-volt source coming through here with the joystick as well, all on 5 volts. Then the analog reference voltage will be on that same voltage. When you move the joystick, it'll change that voltage and be read through our analog pins 0, 1, and 2 for vertical, horizontal, and the switch. Then we'll go through a Arduino sketch and give a converted analog to digital signal out of the transmit pin from the Arduino. And then it'll utilize this transmitter, go wireless to this receiver. This receiver will output digital signal to our pin 3.2 on our MSP432, and that'll utilize a UART to receive it.
Okay, so let's talk about the code. We're going to start with the transmitter. This is a Arduino sketch. We'll go up here to our constants. The most important one declared here is the baud rate. So as you can see, we have it at 1200, which is pretty slow, but we did that so that we could try and reduce some errors. Our transmitter receiver, a little bit lower quality, cheaper part, so we wanted to make sure that they would be able to communicate with each other better. Going down, skip some functions that we wrote. We'll come back to those later. Here in our setup, we utilize the regular Arduino library, and we have our we begin our serial with our put in our baud rate 1200, and then have our 8-bit no parity 1 stop bit, which is standard, and that's what we'll read it out as on the MSP side. So in our main loop, we're going to instantiate a struct that will hold 3 data values, one for our vertical, one for our horizontal, one for our switch. Then we're going to read those values with our read pins function that we wrote, which just takes the vertical, horizontal, and switch pins and then uses an analog read, which is an analog to digital converter, and then stores that value in that structure. From there, we send the data. So it's going to take that structure, parse some data out from that structure because it's the data is 2 bytes, but we can only send it 1 byte at a time. So we're going to parse the data, put it in an array, and then send that array over. So we'll send a start bit first to let the receiver know that the data is coming next, then a message length, which will be 3, but we made it modular, so if we want to change it, and then we'll have 3 values sent over and a stop bit. Then we'll do a slight delay, and then coming back to our main, then I'll just loop over again. So, okay, so now we're going to talk about the receiver side with the MSP432. So I have this calculator up. It says 430, but it still works for the 432. So what this is going to ask is for which type of UART we're using. We're going to be using the EUSCI, and for us, we're going to be using a 3 megahertz clock, which is a SM clock, and standard it's at 3 megahertz. So we can put these values in here. And then our baud rate is 1200. So once we get that, we get our clock prescaler, which is the divider. So it's going to take this 3 megahertz and divide it by this, and then utilize first modular and second modular value to get the required baud rate. So that there's so it's all integers. It also recommends that oversampling. It also says we need to use the oversampling as well. So when we go into our code here, our main's pretty simple. We're going to have some functions that configure our UART, that start our interrupts, and then configure our GPIOs, and then it will start it. We're also going to have an IRQ handler. All this is going to do right now is check for a flag, clear the flag, and then read the data. So it's just going to, from this receiver buffer, put it into our receiver. And as you can see, it's a 1 byte variable. So it's just going to read 1 byte at a time every time we get a flag. So kind of let's delve into these functions right here. So to configure our UART, we need to make sure that it is disabled first. So that's what we're going to do here. And then we want to make sure that it has the SM clock as the clock source, and that's going to automatically be at 3 megahertz. Then this next stuff right here is talking about what we got from that website. So we have our oversampling bit, so it'll start oversampling. Our modular bits are placed in here. So how we did that is, if we look at a header file, so our first modular bit and our second modular bit, that came from the website here, but as you can see, they're in the same register. So we had to do some bit shifting to make sure that they're in the right spot. And it's a 2 byte value for the mod bit, but we don't want to mess with the first 4 bits. So that's how we did it right here with the bit shifting. And then that's going to be put in to this register, and the baud rate word register is going to hold our prescaler or divider for the clock. So after this, we have our clock set up, we have our baud rate set up, and then now we can re-enable the UART. From there, we're going to go into enabling interrupts. That's pretty easy. Just interrupt, enable, and enable our IRQ. To start the UART, all this is going to do is going to read the receiver buffer once, and then that'll clear the buffer. So we don't have any extra stuff that's in there. We're also going to configure our receiver GPIO. This is pretty easy because from here, the port 3 pin 2 and port 3 pin 3 are the receiver and transmitter ports and pins for the standard on the A2 UART. So the EUSCI A2 connects to the 3.2 to receive. So all we have to do is turn on the primary module function for that port. So we can just say port 3 selects, we use that, and then what this will do is make sure it's primary module, and it'll automatically do everything for us.
Debug this. So we're going to be using the Analog Discovery 2. So the only difference here is that we're going to take out the receiver transmitter, and we're going to use the Analog Discovery 2 to see what the Arduino is giving out. So we're going to read it with a logic analyzer, and then we made our own UART code that we're going to send to the MSP432 to test it. We're also analyzing the joystick voltages to see how those change as well. So as you can see here on this screen, on the top one, we have the oscilloscope, and let's see if you can see, if I move the vertical axis on the joystick, you can see the voltage changing. So it's if we have 5 volts, it's going to cut it in half, so it's going to be at 2.5. And then full throw to the north would be 5 volts, to the south would be 0 volts. And then for the horizontal, full throw to the west is 5 volts, and to the east would be 0 volts. So we can see that our joystick is working. I don't have the switch set up, but trust me, it does work. And then on the bottom here, we can see this is what the Arduino is giving us. So if we stop that for a second, you can see that it's in, let's get a good one, it looks like. It's giving us UART. So it's going to have a start bit, 8 bits, and then a stop bit. And that'll be our analog to digital code that it's giving out for the values of the joystick. So we can see that it's working. We're using a joystick to give us voltage, and then we're getting out UART data. So then looking into to test the MSP432, what we did is made some test sample UART data in a pattern generator, and it's just the same thing that the Arduino should be giving out, and that's getting put into the receiver pin on the MSP432. So now when we go into debug mode over here with the code, we can put a breakpoint on the IRQ handler, run the code, and look, now we're putting the UART pattern on the pin, and then it popped into our IRQ handler, which means now that the UART is receiving something. Then we can see down here, we put another, we can see what the receiver value is. So that's 4, right? And then we can just kind of go through this, and it changes. So 2, 0, and these are the values that we were giving it. It's not always the same, just because I can't click as fast as the UART's going, but it's giving me these bytes that we're sending, and these were the actual bytes that were being sent. So it's verifying that we're using the joystick to give the Arduino a value. That Arduino is then taking that value, transmitting it through UART to the MSP. The MSP's picking up that UART, parsing out as we need it, and then giving us that value. So minus the actual hardware of the transmitter receiver, the code is working properly.